Good morning, dear student. Let's wait for another 5 minutes. Good morning, dear student. Someone please stop sharing your presentation. Google Meet. Someone has shared his screen. Please stop that one. That it will consume your bandwidth and you will not able to hear my voice properly. And still joining. Few students are still left. 44 students just joined. Hello. Please unmute your mic. And one request. Suppose if you are using double SIMs, then the one that is not connected to your internet, that SIM, please deactivate that SIM for time being, because someone will call you in that number, automatically that will be cancelled. So please, this one, disconnect the SIM which is not using the internet. Okay. Last class, someone said that someone called in between my class, so I'm not able to join it again. So that's the problem will be occur. So please try to disconnect the SIM. Okay, last 1 minute I will work and I will start the lecture. So my voice is audible or not? Can I start the lecture? Everyone? Okay, then I will start. Okay. So in last class, we have studied about the introduction to the microprocessor. What is a microprocessor? What is the basic difference between a microprocessor and a microcontroller? And what is also different between the microcontroller and the microcomputer also? And different types of generation, the microprocessor has been changed from the first generation to the fifth generation computer. The earliest computer was big one. The processor was a big one. Now can't able to handle the lots of processor at that time. So these are the changes in the computing environment. So and the basic definition of the microprocessor and interfacing with the outside world, that is the input output devices and in memory, and about the memory architecture also we have studied all those things. Memory architecture we have studied. So in today's lecture we are going to study the basic architecture of the i085 architecture and basic introduction to the assembly language. That is the assembly language programming we are going to study in today in our course also. And for that one, we need the assembly language. We are not dealing with the high-level language, just like the C programming or C++ programming. But we are concerned with the assembly level programming to connect and to give the instruction to the i085 microprocessor, because the i085 microprocessor can't understand the this one, your ASCII code or any this one English literature or something like that. So these bits of stream has to be connected to some hexadecimal. Again, some hexadecimal has to be connected to some assembly language programming, also known as some instruction that is called the mnemonics or some shorthand formation of that hexadecimal hexadecimal number, so we can communicate with the microprocessor. This is the introduction. So if I go to the microprocessor architecture, we have already seen that i085 microprocessor is a 8-bit general purpose microprocessor. So if I talk about i085, then there will be 8-bit general purpose microprocessor. So I can able to have a addressing of 64K of memory. That means 2 to the power 16. 2 to the power 16. That means bits 2 to the power, it is converted into the KB, means I will have a 64 KB of memory. That microprocessor can handle this one 64 KB of memory. And again, if I talk about the 16-bit microprocessor, that means I need to have a loss of addressing, the 2 to the power 32, something like that. So as we increase the number of bits of the microprocessor, the capable number of addressing or the memory that can be handled by that microprocessor has been increased. And also the if I talk about the number of pin architecture, that is pin means we are concerning that is nothing but a silicon chip. That microprocessor is nothing but a silicon chip. So how many pins are there for this type of microprocessor, so that I can connect with the internet, output devices, input devices, memory, all those things interfacing. That one, how many input are there? That is the 40 pin input is there, and each input has is different meaning. Whatever instruction is given to the microprocessor, how the input pin has been activated according to the instruction has been instructed to the microprocessor, and the microprocessor with help of register. And someone is joining the class again, disturbing. If you are late in 10 minutes, then don't try to join my class. Others Diwali, don't try to join. In next time, don't try to join my class. If I like that, then don't try to disturb my class. Okay. So we have different types of pin. 40 pins are there in the i085 microprocessor. Each pin has different function to perform. according to the input we are given in the microprocessor. Everyone is joining late. Why? So the architecture that is A085 architecture require a voltage of 5 volt only, and it can operate with the 3 megahertz of clock. And A05 is also known as upward compatibility. That means it can compatible. Compatible means suppose if I say that this RAM is compatible with the i3 processor, that means I can work with that i3 that RAM with that microprocessor. That means I0 upward compatibility. That means I can this I015 microprocessor can work with the earlier microprocessor, can interface with the earlier microprocessor or any other devices or this one. That is the meaning of the compatibility. So this is the basic pin diagram of the microprocessor A05. So looking at this pin layout, we have this is pin number 1, pin number 2 to the pin number 20 in the left side and right side. We have the from pin number 21 to 40. So X1 and X2. This whole again I will discuss in the later part of this lecture. Just a brief introduction of this pin. So X1 and X2 is nothing but a this one is the input of your clock cycle. X1 and X2 is the frequency generator, is connected to the frequency generator, also known as the crystal oscillator. Some oscillator is going to be used to generate your clock cycle. Suppose one clock cycle, how many instructions I can, various type of instruction I can select. So for that one, we need a oscillator called as the crystal oscillator, also known as the frequency generator. This is the input of that one. We are going to connect with X1 and X2 pin with the crystal oscillator. Then we can function by this microprocessor. And again, this one reset out button is there. Reset to again reset in button is there. Again reset in button is there. Reset out to reset again the button again. Starting suppose if I want to start for the beginning of any instruction, I can reset this button with some instruction. That button is not going to automatically. That is not a switch one, because we are going to give some instruction of the reset instruction from the input devices. So in this way, we can have a reset out and reset in SOID number SOIC. This is a serial input data and serial in output data. This is for suppose if I want to give in my microprocessor a series of input stream in the series form, in the serial format, 1111, something like that. So we can directly without going to the address part, we have two options. We have two options to give instruction to the microprocessor by from the address first A8 to A50 is the address first, and again from this one serial input data and this one. So instruction can be given in this form also, and again trap. This trap RST 7.5, IST 6.5, IST 5.5. These are all, and again the interrupt. This one ENTR, and these are all called as the interrupt. These are called the interrupt pins, because in some cases I want some quick decision to be decided whether to uphold your data, whether I need to get back from starting from the beginning, all those things. This all interrupt will be come into later part of the this one. lecture. These are the interrupt. Interrupt is because I want to something this one some instruction is going on. I want to break in middle of that instruction, or again some serious issue is there. So I would not able to go to that instruction. Then that interrupt pin had to be activated. So that I can come out that from that instruction. So basic use of that interrupt pin is that one. So we have this address pin. This is the for AD0 to AD7. We have this address bus and again the data bus. A means address bus, D means data bus. So we are just writing the combined format of the address and data. This is AD0, AD1. That means it is a multiplex data and bus. Multiplex means I just combining the AD, A and D. I'm just combining my address bus and the data bus. So at that time, only one input pin will be activated. Suppose if I want to activate the address, I need to enable this one. This is one of the pin is there. Address less enable ALE. Suppose if I want to activate the address, I need to assign this ALE pin S1. Suppose if I assign ALE pin S1, then this address bus will be automatically generated. Okay. So I can use this pin as an address bus. And again, if I want to use this pin as a data bus, then again I need to assign the ALE as 0. So if I assign the ALE as 0, then again this the data bus has to be generated. So in same way we have the address bus, and again this is a S1. So we cannot see any PPT. Okay. I'm only sharing. Okay. Now I will share it again. So now able to share. So just if we have any problem, just message me on your WhatsApp group. No. Why? Okay. Now just message me. Okay. You have yeah. So I need to repeat again from beginning this pin diagram. Okay. So these are the different pin diagram. I hope you have understood the pin diagram from beginning. Okay. Just see, because these are important. If you know this one, basic architecture, then all the remaining portion will be very much easy. So this is a pin diagram. Pin diagram means here all the input and output has to be input. Suppose if I want to give some instruction from the input, from this pin only I can give the instruction. And again, if I want to take out some after processing, if I want to take some result from the microprocessor, from this input pin only I can extract the output result. So basically I only told that we have the 40 pins. So 40 pins is there, 1 to 20 pins is there, again 40 to 21 to 40 pins is there. So we have first is the X1 and X2. X1 and X2 pin are called the frequency generator pin, or again frequency generator, or again the crystal oscillator. Oscillator means it is going to generate some clock signal. Some clock signal has to be generated, and again after the generation of the clock signal only, I can extract, or I can give the instruction to the microprocessor. So this frequency generator is very much important. Without getting any frequency generator or any crystal oscillator clock speed, we can able to perform the microprocessor. And again, this is also important. Suppose if I have a very much fast clock speed, suppose you have already seen you can go to your PC also and just look at the properties of your computer, and you will see that there is some megahertz or gigahertz. In terms of gigahertz, is there something like that? 2.4 gigahertz of clock speed is there, or something like that. So basically, if I have a very much high clock speed, the process in which the processor, that is i3 processor or i5 processor, that handle the processing power will be very much more. So if I want to buy any computer, I need to buy this one, a PC which is having a very much high clock speed. That is nothing but a frequency generator. That clock speed is going to be generated by the frequency generator, or it is also called as a crystal oscillator. So these are the oscillator. So, and again, the reset button is a reset in button, reset out button. This is basically for the reset of your program. Suppose if I just performing a instruction at the middle, after completion, I want to start from the beginning. Then I need to press this. I need to give the instruction to this reset button, so I can start from the beginning. So this is the function of the reset button. And again, the SOD and SID is nothing but the serial input data and the serial output data. So this is a suppose if I want to give some instruction, I can give the instruction in form of the data bus. From the address bus, I give some instruction, and again from the this one, SOD and SID. This input data means I need to give it support, but if my data is in the form of a serial data. Serial data means suppose 1011 in same format. Suppose this is a form. Then I can instead of giving my instruction from the address bus, I can give my instruction from this SID. So basically, this is for the giving the instruction. So I have two options from the SID and the address bus. And again, these are TREP, RSD 7.5, RSD 6.5, RSD 5.5, INTR. These all are the interrupt. These are interrupt signal. This is also called as the interrupt signal. And this interrupt signal has very much important functionality in this my microprocessor. Suppose in between some instruction, I want to go from that middle part to the this one starting of the program. I want to terminate the program. All those things. This interrupt signal has to be generated. Again, I need to come back from this one, the area where you want to start. That is the interrupt. Basically used to interrupt the instruction that is going on in your microprocessor. That is basically the function of the interrupt program. And again, we have the NTRA. This is the increment or this one accumulator. We need to see again in the later part of this one. And again, we have the multiplex data and address and bus data. We have AD0 to AD7. That means this one, why it is called the multiplex? Because I am combining the functionality of the data and the address. I am combining both the functionality of data and address. That's called, it is called a multiplex data and data. But at the same time, only one of these two, that is the address or the data, is going to activate it. How are you going to activate it? By using this LALE, address less enable. If I activate this ALE as 1, then address will be enabled. If I set my ALE as 0, then address will be enabled. Okay, and this is voltage for the neutral one connected to the neutral. And again, this is a power supply, BCC power supply, and whole is again, it is also some holding some data from this one, and it is also some type of whole program, and it is holding to the accumulator. A means accumulator, and we have the reset button, ready button, ready IOM. Again, this one IO. If this IOM M bar is set to 1, then IO will be activated. That means I can give the instruction from the input devices with this activated. Then again, the instruction has to be provided from the address bus. So if IOM is 1, then IO will be activated. Then again, if IOM is 0, then memory is going to be activated. This S1 and this one, this again S is this S2. This S and this S is again the signal function. And with the use of S1 and this S here, and again the IOM and ready button, we have different combination of this one. And with the different combination, I can give the different input to the microprocessor. You are going to see in later part of the your lecture. With the use with IOM S1 different combination 0. Suppose it is 0 0 1, then the output will be something like 0 or something like that, and 0 1 1. That means output will be something like that. So different combinations. Suppose if I have a 3 combination, 1 2 3 combination, that means there will be a combination. If I have a 4 combination, there will be have a 16 combination, and for each combination there will be having a different meaning. So these are all the signal one, and this is also a RD means read operation. Then WR is a write operation, and already seen that this is the address bus. This is the 8085 pin there. So we can, this is pin 1, and again I draw in this one. This is another way of representation of this pin diagram. So this is basically the same one, just a modification. So these are all the S1 and S2 are the clock signal that will be provided by the crystal oscillator or the frequency generator. This is a ground one, or this is the voltage supply 5 volt. And again, we have seen the address bus from the AI to A15. This is called the high order address bus, and from the AD0 and AD7, this is the multiplex data bus that it can be function with the address or data at a one time only. That will be activated by using the ALE unit. And again, this is all the interrupt, the trap, RSC. This is combined because this is one of the, this is the all are interrupt. This all are combined because these are all called as the interrupt program, interrupt signal, and this is called the serial I/O ports. This is for a serial communication. For a serial communication, in my data is coming in a serial wall, or if I want to give my instruction in the serial communication, so serial I/O port is there, SIO is. And again, the acknowledgements, the NTR is the acknowledgement, and this increment and SDA means all acknowledgement. This is all the acknowledgement one. Then again the signal one, SO I1, this one is the signal status. This is S0 and S1 is called the status signal, and again the IOM, RD, SR are called the control signal. Because why it is called the control signal? Because from this signal only I can write some instruction in my PC, in my microprocessor, and again the output result has to be given value to the output devices by using the write operation. That is called the control signal. Control signal basically used to transfer some information in and out from input devices to microprocessor to the output devices. That is handled by the control signal. So we have the system bus. System bus is nothing but the wire connecting to the memory and I/O to the processor. So you can see this one. This is the address bus. This is the address because this is the output device, serial output devices, and again it is connected with some eraser. This is accumulator is also one type of eraser, and this is also temporary eraser. It is connected with microprocessor. These all are the function of microprocessor. So this is the system bus. This is the internal bus, or it is called as the data bus also, and this is also called as the system bus. So system bus can be divided into 1, 2, 3. Three types of. One is the address bus. Address bus is the having a unidirectional address bus where your address information or the instruction has to be provided from the address bus only. And the data bus means it is the having a bidirectional. Bidirectional means in both directions. If I say the bidirectional, unidirectional, only one direction I can go through. That is called the address bus. But in the data bus, in both the direction, suppose if I write something and again the output can be given back to the user. So basically data bus function is having a bidirectional. In both directions, the address data can be read, and again for another direction it can be write. So this is for using the transferring of that, because if it is not a bidirectional, then I need to wait till the completion of my whole instruction. Suppose if I have if I give 1,000 instructions at a time, then I need to wait up to the finishing of the document. If it is not a bidirectional, I need to wait till the 1,000 instructions to be finished. Then I need to see. I need to see the first instruction result, second instruction result, and third instruction result, so on. So it should be having a bidirectional, because the read operation and write operation simultaneously. I need to see whether my this one instruction has been correctly calculated by the microprocessor, executed by the microprocessor or not. And this again we have the control bus, and this is used for the synchronization of the signal. And again the timing signal, control signal, by using different status and control signal. And the synchronization of the signal. Synchronization means, suppose why the synchronization is needed. For every PC, for every devices, synchronization of my signal is very much essential. Suppose if I have a two PC with me, suppose the clock speed of my PC, one PC is very much high. It is very much fast. I can handle my process, all the instruction very fast. That means after finishing of tasks, the information is going to be forwarded from that one PC to the another PC very much fast. But at the same time, if the second PC is not having a very much high clock speed, then it will not able to capture the data, because the rate of the transferring from one PC is very much higher as compared to the rate of receiving the signal. So in that case, what we need to do is I need to slow down the slow down the transferring rate of my first PC, so that the receiving end will not find any difficulty in capturing those data. So this is the synchronization. Suppose if I going to interface, suppose why synchronization is needed? Because if I have a I085 microprocessor, I want to interface with one microcontroller. I want to interface. I want to communicate with my microprocessor and my again one with my one microprocessor. Suppose if the clock speed of my microcontroller and microprocessor is not same, then it is not able to fully function your whole information. I will not able to convey the information from my microprocessor to the microcontroller and from microcontroller to the microprocessor. So I need to have the proper synchronization of my data. So this is the need of the synchronization. So this is the architecture of the Intel. This is the i05 microprocessor. Is called the Intel microprocessor. So this is we have already seen from the pin diagram that these all are called the interrupt control, serial I/O control, and again we have seen that we have the different types of system bus. One is called the data bus. This is the example of the data. This is the data bus. From this side to this side, this is called the data bus. And again, we have the address bus also. This is called the from the address. This is address bus. From the address buffer, it is going to the data bus. And again, we have the control bus. This is called the control bus. From the timing and control bus, instruction area. So we have this architecture is very much important. You need to remember. You need to draw again and again to know what is the basic architecture. And again, how to remember this one is very much easy. So how do you remember this? Suppose if I want to give some instruction, then instruction is going to be given from the data bus. Data bus. This is the data bus again. So suppose if I give some instruction that is from the data bus, I activate with the ALE. ALE1 means address will be activated, and again from the activate to address bus, from this data bus instruction has been forwarded to my data bus. This one from address bus to the data bus, and from the data bus I can give to the instruction register. Instruction register will hold the information, and again the instruction register will forward that message to this unit. This unit is called the instruction control decoder. Why we need the decoder? Because the instruction is in form of some mnemonics, some handwritten. Suppose 8B. 8B will not be understand. You will only understand in terms of the bits. That instruction is going to be decoded by using this decoder. That is called the instruction decoder and the machine cycle encoding. Then after the instruction has been decoded, the microprocessor will understand what actually the user want to convey the meaning. What type of instruction? 8A is going to be understood by the microprocessor. Then by using different control signal and different control signal, by using the different control signal, we can calculate that instruction. Then it will be given back to the address. It is given back to the address bus, and the output will be generated. So here we have, this is the flow of the data from this one, from address bus to the address bus to the data bus to the instruction register to the instruction decoder and so on. So here we have different types of register. This all register is inside your microprocessor. One is called the accumulator. This is A register, and again the temporary register is there, and again some flag flip-flop. Flip-flop is one circuit. You're going to study different types of flip-flop. in the digital electronics. No need to go detail, but these are some you need to remember. And you need to remember that there is some circuit which is going to be used for some flag. Suppose if one carry is generated while performing the one carry flag is there, that is called the carry flag or carry flag drop flag. Something some flag register is there for some type of register. And again, from the temporary register, and then we have the accumulator. And accumulator is going to come across in different assembly language. We are going to study the assembly language. This is accumulator is going to be used as an operand. Suppose A plus B. A plus B, what is meant by operand? Means A and B is the operand. Again, plus is called the operator. So A plus B, that operand, this accumulator can be used as a operand in my instruction. You're going to study different types of instruction by using the accumulator as a register. You're going to study. These are all the temporary register. Why temporary register is there? It is also of the 8 means 8 bits. 8 bits of accumulator is there. Temporary register is also having a 8 bit of information. 8 bits of information, and then flip-flop is also at 5 bit, and instruction register is also at 8 bit. But why there is the need of temporary register inside the microprocessor? Why we need the temporary register inside the microprocessor? Can anybody comment in the comment box? Why we need the temporary register? Because we have already. Suppose if I have a microprocessor with me, already there will be RAM will be there, ROM will be there. Why we need this register inside the microprocessor itself? Why? Can anybody to store temporary information? That is again correct. Why? Why we need to store the temporary information in the temporary register? Why we need to store that one? Just go, maybe a buffer, maybe a buffer for time being. Buffer means for the time being, for a small communication, I need to store that information. But why? That information I can store in the RAM also. I can store in the ROM also. Why? Because it is needed from time to time. Yeah, might be one reason it is needed for runner, but one student answered that one for fast communication. So by looking at going back to the last lecture, we have seen the hierarchy of the memory. So if I go from the magnetic tape to the hard disk to the RAM, again to the register, that one, if I go to the above one, the storage is very much small, but it has a very fast communication or fast processing power. So if I need to have some instruction that is going to be generated in a very fast time, then I need to store the instruction in the temporary register. But the size of the temporary register is very much small. So whatever the instruction that is one cannot be handled by only the help of the temporary register. So we need another type of register called as this general purpose register. We have the 6 type of general purpose register. One is the VDICEL. This is general purpose register. This register is called the general purpose register. But you see that this is B register. It carries of 8 bit. D register is carry of 8 bit. I register is carry of 8 bit. C register is carry of 8 bit. E register carry of 8 bit. Again, L register is carry of 8 bit. So at that time, if I say that at that time my instruction by using the B register, I will only able to handle the 8 bit of information only. I need to I can perform my instruction of 8 bit only. But if I want to perform by using the 8085, that is the 8-bit microprocessor, by using this one, but I want to perform a 16-bit instruction, then I can use the combination of B and C, D and E, H and L register. By combining this B and C, D and E, H and L register, I can perform the 16-bit instruction. So if somebody said that whether I05 can perform the 8-bit instruction, your answer will be by using the only one register I can't able to perform, but I can perform the 16-bit instruction by using the combination of B, C, or D, E, or S, L. I can perform the 16-bit instruction. So this is your answer. Your answer will be I can perform. Yeah, obviously, I can perform 16-bit of instruction by using the combination of B and I, C, D and E, and I and L register. And again, we have another register that is 16-bit register. This one, stack pointer. And again, the stack pointer is again pointer. Pointer means it is basically used to point the address of a variable. It is usually where you store your variable. So if I say that at a particular location 101, your variable is stored. So don't need to go to the direct value. If I go to the direct address of a particular individual, I can get that particular individual. So no need to go to the direct physical part. Just go to the address of that one, and we can find that particular portion. In the same way, some stack pointer is there, and again, it is going to be store the address of a particular instruction. And again, the program counter is there. Program counter is used to whenever I need to perform any instruction, that program counter has going to be set the program counter after completion of the program counter. Again, I need to reset to the 0. And again, when we start the program, again, it's another instruction that program counter need to again restart. So program counter basically it is used to know the starting of your next instruction. If I have 100 instruction, I need to again program counter need to be initialized to the 0 initial after completion of a one instruction. So we need again we have the different types of incrementer, decrementer, address list for the increment operator or decrement operator. We have another address list. Address list means it is another for the address list. List means if we want to have a one generate the increment operator, I need to reset with 1. And again, if I to address less, if I reset to the 0, then decrement operator will be there. And again, the timing and control is all the different types of control signal. DMA, that is the reset button is there. And again, this is the multiple DMA. What is the DMA means? What is the DMA mean? Multiple, we have this one, direct multiple access. This one, multiple processor. We have, suppose if I have a multiple processor with me, we had a multiple processor connected to the same bus, talking to the same power. Suppose if I have this is a same bus. One bus is there, and again the multiple processor is going to access that particular bus. So it will handle by this DMA control by using the DMA hold and DLA acknowledgement. Because suppose if I have only one, suppose you understand or not. Suppose if I have an address bus with me, this is one address bus. I have 1, 2, 3. This is a processor 1, processor 2, processor 2. At the same time, I want to access this address bus, system bus. So we have 3 processors with me. So I need to access, this processor 1 can only access at one time only. So I need to activate the whole. I need to activate the whole button for this one only. Then after the completion of that particular processor, the processor का काम जब खत्म होगा तो information देगा कि whole acknowledgement ALDA, the whole acknowledgement information is going to be transferred back by this processor to this address bus. So next time processor 2 can use this address bus. So this is for the interfacing of the different processor. If I have a different processor with me, I can access the same bus from different utility. For this one for one utility, this one for this another utility, this 3 processor for another utility. The different utility I can have this one. So basic function of this one all button is. So we have seen that Intel i05 microprocessor consists of control unit that will control the microprocessor operation, ALU for the arithmetic and logical unit. Beside the ALU, we have the register, temporary register, general purpose register for the internal storage. Inside the microprocessor, we have the interrupt, different types of interrupt, RST 7.5, IST 6.5, 5.5. All those things are all the interrupts and internal data bus. We have the internal data bus, system data bus, address data bus. All those are the consists of the microprocessor. Microprocessor consists all this unit. So if I talk about the ALU, so we have already seen that this is the unit where you are going to perform the arithmetic and logical unit. And again, we have inside the ALU, we have an accumulator. We have seen that accumulator is of 8-bit information. It carries 8-bit information, and this accumulator is going to be used as an operand in my instruction. If we see the assembly language program, assembly language instruction of the 805, you will come across different instruction that has the concept of the accumulator. And it is going to be the basic beauty of the accumulator is that I can use this accumulator for the storage of some number, and again I can write the information at the accumulator also. Read and write I can done in the accumulator also. And basically these are the register inside the microprocessor. And again we have these are that temporary register ALU that has the temporary register, and again this accumulator. It is only for the temporary storage of the temporary storage of your instruction only, and it is not directly accessible by a programmer. Only the programmer can do is only to give the information. Instruction can be provided by, but I can handle or I can change the whatever the instruction is stored in the register. Only the instruction I can provide. So we have the register. I already seen that we have this 6 type 1, 2, 3, 4, 5, 6 8-bit register, and this is for 8-bit register. I can perform a 6-bit instruction by using a combination of this one B and C. But I can combine with B and D here. Only B and C I can combine. D and E I can combine. I said I can combine. Other combination I can't combine. Okay. So we have this 1, 2, 3. So we have 3 register. By combining the 6 register, we can perform the 6-bit instruction. So I and L, ICE and L can be used as a data pointer. So another is the ICE and L can be used as a data pointer to hold the memory address, just like the pointer in C. Pointer in C means I need to hold the address. I need to variable. I need to see the address of a particular variable. I need to have the concept of the pointer. So data pointer means I need to hold the memory address of a particular. I want to use a particular instruction. That means I can use by using the ICE and L, just like the pointer in C. So again, the special proposed register that is called the accumulator. This is called the IP register. Again, it can store the IP information and it can store the result of the operation. And again, it can store in the operator. So again, I always say that it can use it for reading an information after performing a task. I can given back the information back to the accumulator also. So this can be used as an input and output operation also for a particular task. So we have the flag register. We have seen that we have different flip-flop. That is flip-flop is nothing but a circuit. And again, we have the flag register. Different flag register is there. So we have the 8-bit of flag. So S indicate the sign flag, Z indicate the 0 flag, AC indicate the auxiliary flag, again the B indicate the parity flag, and again the CY carry the carry flag. So just I write this D0 to D7 because from D0 to 7 carries the 8 bit of information. So I write this one in this one C1 CY there EX PX AY X this one Z and S. So what does this X means? It has not applicable. It has not applicable, or it does not have any carry flag in this particular location. It is free. Particular location is free. X means it has not applicable, or it has no any sign flag present in this particular location. So if I indicate X here, that means in that particular D1 there is no carry flag. This one carry flag because I need a bit register, but my sign flag is having only one. We have only in I05. I have only 1, 2, 3, 4, 5. So basically the 3 will remain. So I put this one D1 as X, D3 as X, D5 as X. So I can perform the different flag register. So first one is the D7. D7 means F. It's called a sign flag. It is used for indicating the sign of the data is the accumulator. So if I give some information, and the result of my particular task, suppose 2 minus 1 is nothing but minus 1. The result is minus 1. Then this sign flag is going to be generated. If it is negative, then automatically this flag register will be generated or set to 1. So if my sign flag is negative, and if my sign flag is positive, 2 plus 2, that is 4, then it is going to be positive generated, this one. And again the 0 flag. If the result after the operation is 0. So is set an increment of the increment operation of that register. It set throwing an increment of the suppose if I have 2 stream. This is 1 stream, and again this is 2 binary stream. Just add this number. 1 means 1 addition of 1 and 1 and 0. 1 means 0. 1 0 means 0. 1 0 0 0 again. So if the result is 0, then I will have this one. So suppose 2. 2 minus 2. This is example of carry flag. Suppose 2 minus 2 is 0. 2 means in terms of 0, 0, 0, 0, 0, 1, 1, 0. So 2 minus 2 means 1, 0. And again 2 minus 2 is 0. So if I want to subtract this one is 0. So addition of 2, the subtraction of 2 and 2 is 0. If my result, I need to see the result of the my operation. I need to only see the result of my particular instruction. If it's 0 means the 0 flag will be obtained, and it is not the 0, then it is 1. So on. So this is 0. Again, this is an example. So it is 1. In this case, it is 1. This same one. This is also 1, 0 means 1, 0, 0. This 1, 0. So carry flag is if there is a carry or borrow from an arithmetic operation. Suppose if I have a binary addition and binary operation, if I have a carry and if I have a borrow, that means I need to have a this one carry operation. Do you know how to add two binary number? Anybody know? I need to explain this one. Yes. Addition, subtraction. Yes. Might be you will be knowing that one, but not subtraction. Okay. Just remind with the addition first, then I will simple method for the this one subtraction. Okay. So for the addition, I need only this information. Suppose 1 plus 0, that is 1. 0 plus 1, that is 1. 1 plus 1, that is also 1. Okay. And again, it has 1 carry. This is the combination logic of the addition operator. And again, if I this case also 1, 1, 1. 1, 1, 1. That means the result will be 1, and again 1 carry will be here. You need to remember for the addition one, we need to remember this one. 1, 2, 3, 4. This formula. Why? It is 1 plus 1, 1, 3. If I have a digit sum, that means 1 plus 1 means 3. So 1, 1 means what? Is again, it is also a 3. So I validate the result again, 1, 1. So for addition, we need this one. So just look this formula for the addition. 1 plus 0 means 1. 0 plus 0, again. 0 plus 0 is again 0. So 0 plus 0 means 0. 1 plus 1 is 0. Again, 1 is carry here. So 1 plus 1 is again 0. 1 carry is here. 1 plus 1 is 0. Again, 1 plus 1 plus 1. Then 1 carry is there. 1 plus 1. Then 1 plus 1 plus 1 is 1. Again, 1 is carry here. So 1 plus 1 is 0. Again, 1 plus, again 1 carry is there. 1 plus 0. Again, 1 carry is here. So we have 1 carry. So if I have a 1 carry, then carry flag will be generated. So if I talk about the this one subtraction part, you need to have this one. 1 plus, you need to remember 1 minus 0. 1 minus 0 means 1. Again, 1 minus 1, it is nothing but again 0. Then again 1, 0, 0 minus 1 means 0 minus 1 means what? Minus 1. It should be minus 1. So 1 carry will be there. 1 borrow will be there, and borrow will be at, again, I will have at this one, 0. So borrow will be there, this one. So by looking this one, I can have this one. So basic, suppose if I have this one, 1, 0, I need to minus with this one. 1, 0 minus with 1. That means 1, 0 means 2 in the decimal 1, and 1 in binary, and 1 in decimal 1 is also a 1. So the result should be 1 plus my 1 minus 1 is nothing but 1 here. The answer should be get is 1. So how you going to perform is 0, 0, 0, this one, this should be 1. Suppose this one, I'm going to subtract from 0 to minus 1. Cannot be subtract. So I need to borrow this from this one. So if I borrow anything, just put in this number as 2. If I borrow anything from my succeeding one, if I borrow anything with succeeding one, put the preceding one, just put above this one as 2 here for simplicity. For ये वाला substitution में easy रहने के लिए आप सब preceding में जो 1 है तो उसको borrow करना है यानी उसके बगल वाला में आपको 2 लिखो और again this has been changed, 0 has been changed to 2 here, and again 1. Now it is borrow to this one, so it is changed to 0 here. So 2 minus 1 is 1. So now 1 has been changed to 0, that is 0, 1. So the answer is 1. समझ में आया? So again example ये देखो 1, 0, 0, 1, 0. I need to subtract this one. So I need to subtract this one. So 0 minus 0, I can subtract 0. So 1 minus 0, I can't do 0 because this is smaller decimal. I need to borrow from here. So if I borrow from this one, just write 0 here because nothing is left here, and just put here 2. So 1, 0, 2 minus 1 is nothing but 1. That means just verify the result again. 1, 1, 0, 0 means 4. 1, 0 means 2. Again, 4 minus 2 is nothing but 2. Understand this subtraction part? Hello? Everybody understand? What happens if we do 0 minus 0, 0 minus, your question is 2, 0. This one. This is I can't borrow anything from this one. So if I want to borrow, this is nothing. इसका मीनिंग क्या है? साइन नेगेटिव वाला आएगा. This this is nothing but this is 3. 0 minus 3 means minus 3 आना है, ठीक है? तो माइनस वाला -3, जो ऐसा वाला -3 वाला इसका सबट्रैक्शन अलग है, थोड़ा सा सबट्रैक्शन अलग है, साइन वाला सबट्रैक्शन है ये वाला. So in case the result, if I want to have this result, this is nothing but 0 minus 3. It should be -3. But due to the convention, suppose if I want to have this one, I need to borrow. For this one, I need to borrow 1 also. I need to borrow for this one. I need to borrow this one also. And this one negative 1, 0 minus 1. 0 minus 1 is 1. 0 minus 1 is 1. Again, 0 minus 1 is also 1. 0 minus 1 is, I need to have some borrow. So, it is having 1 here. So, this is nothing but sign convention. Minus 1. Or you can say that this is 0, 0, 0, and 2 below. And this is also a, just take this one, 2 part only to borrow information, and you can have this one. This is basically the sign information. So look here. If I have a 1, 0, 1, 0, that is 1. Again, 0, 0 means 0. And again, 1, 1 is 0. Again, I need to borrow this one from 2. Here 2. 2 minus 1 is 1. Again, this one is, this is 0. The 1 has been changed to 0. The 0 minus 0 is 0. So 1 minus 0 is 1. So again, 0 minus 1 is 0, minus 1 is 1. I need to borrow from this one, 1. Again, 1, 0 minus 1 is 1. Again, 1 borrow is there. So if borrow is 1, again, it carry flag will be generated. Okay. So this is the addition and the subtraction of the binary for the carrier. And again, the auxiliary carry flag, if it is set, if there is a carry out of bit 4, bit 3. Suppose I have some bit of information. Suppose 0, 1, 1, 0. 0, 1, 1, 1. Suppose this is first bit, this is 0 bit, 0 bit, 1 bit, 2 bit, 3 bit, 3 bit. So if some calculation has been done here, if some carry information has been generated from this one, this bit, there can be any carry information or borrow information. Suppose it happen to be generated from this one to the corresponding this bit, then this auxiliary carry flag will be generated. And if I say that what is meant by parity flag, that means suppose my instruction is this one, 1, 1, 0, 1, 0, 0. This is my instruction. 1, 2, 3, 4, 5, 6, 7, 8-bit instruction is there. So if I give this instruction to the microprocessor, so how you are going to find the parity? Just count the number of ones. Count the number of ones. So just count the number of 1. 1, 2, 3, 4, 5, 6. 6 means even. So if even number is there, I need to set as 1. If it is odd, then I need to set as 0. So these are the parity fact. Just for the parity fact, I need to only count the number of ones. And for the auxiliary carry flag, I need to see whether my heartbeat is carrying a carry bit or not. Just carry bit or borrow bit. Any carry information has there or not. Just you need to check that information. So again, we have seen the program counter. Program counter has this one different, and it is used for the different sequencing of your different instruction. If I finish one instruction, the program counter is going to be set to 0. Then again, process has to be generated, and again, next instruction has to be generated. So program counter is there. Program counter has to be set to 0 at the starting of the my program. And this is also hold the address of the next instruction. And again, the instruction of the next instruction and hold the address of the next instruction also. And it has a 16-bit of byte. And again, the stack pointer, I already discussed this one. This is the 6-bit register, and it is the memory. This pointer point to a special called the stack. And if I say the stack pointer, then it will store my address in form of a stack. That means stack means last in, last out. So suppose stack means address will be just like a informal stack. Stack means I can have a stack of books. Stack of books means this is one book, one above the another. I have piled my book. This is called a stack of my book. I have 3 books with me. I just pile my one above the another. This 3 books. This is called a stack of book. So stack of book. If I have some stack of book memory location, this is some memory location 0F. Suppose it's a 0F1 something, 0FF2 something. This is address 1. So this if I store in form of my instruction in this stack format, then it will be formed in the this fashion. Last in, last out, because the last instruction that will be performed at the last one. This one, the nearest instruction will be performed newly without waiting for this instruction to be finished, because this has to be finished first. So this is the form of a stack. So we have the non-programmable instruction that is called the instruction register and decoder. We have already studied that this is the one instruction register, because in the instruction register, we have the decoder that will decode the instruction that is coming from my user end. So it will decode the information, because the user end information is not understood by the microprocessor. So it will need to be decoded to by the instruction register, so that the microprocessor can be understood. So if we have the internet clock generator, we can have a 3.1 megahertz of internally and 6.5 megahertz of externally. That is called the clock generator to generate the X1 and X2. This is clock generator. And again, we have this is already we have studied, this one, address and the data bus. We have the address 85A8 to A15, that is called the unidirectional. And again, the multiplex one, this is called the bidirectional. And this is, we can, at the same time, address can be generated, or this one, data can be generated, or data can be functioned by using the ALE pin. ALE is set to 1, then address will be generated, and ALE is set to 0, then address can be used for my function. So if I talk about this one, AD7 to A1, this is called the multiplex and demultiplex. Multiplex means I can simultaneously give the instruction, and again, demultiplex means I can have this AD7 this is for dual purpose. Dual purpose means for the address bus and again from the higher bus. The high order bits of the address remain on the 3 clock cycle. However, the high order bits, what is meant by high order bits? High order bits, or also called as the high order address bus. What is meant by high order bus? If anybody understand my lecture, what is meant by high order address bus of the H085? High order address bus. Someone please comment. High order. High order address bus. Don't know. I already give lecture about that also. High order address bus means the address from I0 to this one 15 is called the high order address, and the low order address bus is called the from the this one A0 to AA. This is called the low order bus. So for the higher order address bus, it remains for the 3 clocks pattern. Suppose if I have a 3 clock pattern, clock 1, clock 2, clock 3 will remain the address, the whatever instruction will be given at the high order bits will remain till the completion of the three order pattern. But however, low order bit remain for only one bit on one. Suppose if I want to give some information, it will remain for only one clock cycle. For if I give instruction to the low order bits, low order bits means A0 to A7. So we have the external latch to save this one for getting address bus and data bus. We use the ALE to enable this latch. Latch means some circuit is there. ALE latch to enable this one address or data bus. We enable the ALE signal to use the address bus or the data bus. So if I see this one, this is called the high order address bus, and this address is called the low order address bus. And if I have this one, this is connected to the I01, and this AL is enabled. This AL is enabled so that we have an address bus, and again we have the data bus. Because of this AL, if AL enable one, I can have the address bus, and again if it is 0, set to 0, then I can have a lower order address bus. So this is only where I know, and I already said that this higher order bus can have a 6 bit of information. This one 3 clock cycle, up to 3 clock cycle, I can have this one. And for lower information, we can have a for lower information, I can have a only 1 clock cycle. For 3 clock cycle, the information instruction has to be remain for the 3 clock cycle. But for the lower address bus, the instruction will be available for only 1 clock speed. This is the thing. And this is the again the pictorial representation. This is the high order bus, low order bus, and this is the address bus. This is the circuit diagram. Actually, this is a circuit diagram. If I want to represent, you want to make a circuit of my microprocessor with this different type of data, this is the circuit representation of this one. And again,
we have
class.
We have another class. Yes, sir.
Yes?
We have another
Okay.
class.
Just it's only finished. Just assembly. Just I will like to have in next Monday class. Okay. Then just look this operator. This is M2. This one also. Just try to connect with this picture with this one. Okay. Let's see in the next class. Just remain for 1 minute. I've already taken attendance at 2-3 times. So just to have the attendance. Just wait 1 minute more. Just okay. Let's meet at Monday at same time. My class and timing. I can discuss with the different instruction set and assembly language programming. Okay. Okay. You can leave now. Thank you all for your kind patient hearing. And please try to read the textbook. Without you will not be able to understand. Okay.